All right, electron affinity is the energy change associated with the addition of one electron to a neutral atom. And already we see that this, while it might seem vaguely familiar when we compare it to the ionization energy trend, it's actually going the other way. First off, ionization energy is an amount of energy that you have to put that into this process. Not only that, you're removing an electron. With electron affinity, we're adding an electron, and there's an energy change. What that means is there are atoms out there that by adding an electron, they become more stable. And what that means in math terms is you become more stable, you're having energy leave your system, and so the total amount of energy in your system is becoming less. And so the energy change is going to be a large number, but it's going to be negative, okay, because energy is leaving your system. If an atom has a very large negative value for electron affinity, that means that it is going to become significantly more stable by gaining that electron. If it has some sort of less negative number, it means it's still going to become more stable, but not as significantly more stable as that larger, more negative number. All right, and electron affinity has a trend that says we are actually going to become less negative as we go down a group, and we're going to become less negative as we go from right to left in the periodic table. And again, I'd like to contrast this with ionization energy. Okay, ionization energy. Ionization energy was increasing as you go to the right. Now we're becoming, we don't like to say it's increasing, but we like to say that it's becoming less negative as we go to the left and also as we go down a group. Now the reason this is because we are going to approximate a noble gas electron configuration by adding electrons. The way we indicate an increase in stability, right? Because remember, when you have an electron, when we have a noble gas electron configuration, you're very, very stable. The way we do that is we're going to add electrons until we get that noble gas configuration. Oh, sorry. There you go. The way we represent that mathematically is we say that there's a certain amount of energy leaving the system, and we know from general science experience that nature favors lower energy situations. For example, if you have a pen and you leave the pen alone, is the pen going to go up a hill? No, it's going to go down a hill, right? And I saw you rolling your eyes, but the he saw it. Automatically, walk into chemistry class, eyes roll. The reason that pin is going to go downhill is because there's less potential energy down there. You're decreasing in the amount of energy as you go down that hill. Nature favors lower energy constructs. That's why you fall down, right, instead of falling up. And so nature is always going to favor a lower energy situation. So if we're having energy leave the system, we're having a lower energy situation. And we represent that by having a negative number. Okay, we're having a negative number. And so the larger this negative number is, that means the greater the increase in stability by the addition of that electron. The smaller this negative number is, that means the less increase in stability you're getting. And so it's not going to be favored quite as much. Everyone's favorite electron affinity.